Wow, how's everybody going? We're doing. So if you want to take a look, today we are coming to you from the gymnasium. So a change in atmosphere, change in environment. We'll see how this goes. So this week we covered how to use the ratio for tangent, we covered how to use the ratio for sine, and we covered how to use the ratio for cosine. I have met with a couple people individually. If you still need to have some time with me, please contact me. We'll set it up. I'll take as long as I can, or as long as need be, to make sure you're understanding these concepts. So a quick review of where we are so far. Right now, all we've done is we have taken a triangle, okay, and using that triangle and the ratios, we've determined how to set up the ratio and how to calculate to find the ratio that we're looking for. First things first, something to remember, the acronym for us is SO. Ka. Hope I'm not dropping stuff here. SOHCAHTOA. Okay, now I usually write this on the top of my sheets that I'm working on just so it's a remember for me. If you want to do it, that's a great practice. Just remembering. Now, before we move on to an example to review, let's take a look at what these actually mean. So SO stands for sine. The S in SO stands for sine. The O in the word SO stands for opposite. And the H stands for hypotenuse. So it's an easy way to remember that when you're working with sine, so that's the ratio. We're taking a look at Ka, the ratio for Ka when we're working with it in trigonometry. C stands for cosine. The A stands for adjacent. And the H for hypotenuse. Okay. Now finally, if we take a look at tangent or TOA, the T stands for tangent. The O stands for opposite. And finally, the A stands for adjacent. That's making sure that we have our formulas that we're going to be using. Now, how does this apply? Well, as I was talking to one of your peers, when you take a look at the actual triangles, setting it up, one of the parts is really easy. The hypotenuse is never going to change. This is always the hypotenuse, okay, the longest side. And it is across from this angle, this little square, meaning right angle, means the value of this angle is 90 degrees. It doesn't change. Okay, so a quick review of that. Those two are always given, never change. Now, the other sides, the opposite and the adjacent, they do change based on the location of the angle you're looking for. So if we're looking for this angle here, okay, my funky little wagon wheel, now we can actually distinguish or determine where the other sides are. So looking at this picture, what side is opposite of this angle? Well, we go to the opposite side, we should be here. This side becomes opposite. Well, that would mean that the only one left over is adjacent. And then adjacent means like somebody adjacent to you is like somebody you get to hold hands with. Well, this one's far for this angle to hold hands with. So this side becomes adjacent. I've now labeled my triangle. I can now, when given numbers, manipulate the ratios and see how it's done. If we take a look and we switch the location of what we're looking for, the hypotenuse and the 90 degrees still don't change sides. They're where they are and where they're going to be. But if the angle we're looking for is now here, well, what side is opposite this angle? Is farther away. And which one would this angle hold hands with? Makes this one the adjacent. Well, now that we've labeled it, what do we do now, Mr. Ryan? Well, that's quite simple. If we're going to take a look, we'll put up one question here, figure out how it's done. I'm going to move the triangle over a little. Actually, I'm not going to move the triangle over. I'm just going to move my board over so I have something to work with. There. That's a little simpler. Now, let's say we're actually trying to find this angle, and we are given the following numbers. Now, through Pythagorean theorem, these numbers do equate. They actually do fit the triangle. That's always also something that I could ask you to do, is to make sure that these work, and they do. If you want a quick little adage that they do to work, okay, it's 3 squared plus 4 squared should equal 5 squared. That's 9 plus 16 should equal 25. Both sides are 25 of the equation. Therefore, these numbers are accurate. Get rid of that because we're not going to need that right now. Now, let's say, for example, you get a question and I give you sine of theta equals what? Give me the answer. Okay. Well, we know we're going to use the sine ratio, which is this guy here. So sine equals opposite over hypotenuse. Now we label the sides first. Well, we know this guy is the height. This guy, because he's on the other side, is our OPP. This guy, because he can hold hands, is our ADJ. Now we've labeled them. Next step becomes relatively easy. Right? We rewrite it. Sine of theta equals opposite over 4. We rewrite it again. Theta equals the sine of -1, because that's how we punch it in our calculator, equals 3 times 3 over 4. Now, that looks a little hard to see. I'm going to switch back to black. There, much better. Now, we take our calculator, we punch in the numbers, we should come out with theta equals 53 degrees. Now remember, when we're punching it in our calculator, on our web-based calculator, you find it, you hit the -1, or sine -1 first, then you go 3 divided by 4 and hit equals. I would only round to 1 decimal point, okay, or just leave it without the decimals behind it, unless it's blatantly obviously, like if it was 5.8 or 53.8, put it at 54, okay? But aside from that, that's how you set this up. Now, if you were to flip these numbers, and now we were going to find cosine, basically same premise or same background, the sides don't change. Once we've labeled the triangle, it doesn't change. Just how we use the formula does. The cos of theta, that's the formula for cos. So the cos of theta is going to equal the adjacent over the hypotenuse. Now, when you punch this in, remember we punch it in, cos is -1, 4 divided by 5. You're going to get the theta is equal to 53 degrees. When we go through the tangent, we're going to find that all of these ratios for this triangle, looking for this angle, is going to give you 53. The reason? Well, if it gave you different answers, we'd be doing the math wrong. We don't want to do the math wrong. That's pretty much reviewing how to do that. Now, the next step that we're going to go through after we take a look is what happens if I just give you 1. But that we'll save for a different video. If there's any questions, please, like some of your peers have done, fire me a message, whether it's through the text app, whether you're going to send it through Google Classroom, whether you're going to email me directly. Send me the message. We'll set up a time. I'll make sure that we have something that you can actually watch me do the work. We'll work through the problem, even if we have to go back. I just need you to make sure that you know how to set up the ratio, or what the ratios are, how to set up the triangle, how to put them in, and how to get the angle. Let's determine. Okay? Hope it's okay. Tomorrow you're going to be looking, or very soon, you're going to be looking at a small summative assessment on doing them. Please make sure you get your work done, and we'll see you soon. I'm going to try to stop recording this now.